Okay, ji. Assalamu alaikum. So I'm going to solve this upon request of a student. This is May, June 2021, paper 31. So the first part basically is real numbers are stored in computer systems using floating point representation with 10 bits for the mantissa, 6 bits for the exponent, 2's complement form for both mantissa and exponent. So that's important. 2's complement is being used here. Calculate the normalized floating point representation for minus 7.25 in this system showing you working. So whenever you get a question of minus 7.25, it's pretty easy. All you have to do is, I will first of all do is, I will consider this as, let's say, plus 7.25. So if I have 7.25, this actually means is that in the exponent, what I will have is over here is 0 and 1. Well, obviously, you know, is what I have over here is 1 over 2. Then you have 1 over 4, 1 over 248, so on and so. So 1 over 4 is basically 0.25, right? So this is how we get 0.25 in positive. So that's not an issue. Then we have is plus 7. So plus 7 can be represented is by 1, 1, and 1. So 1, 2, 4. If you add 1, 2, 4, you get 7. I hope that's also clear. So we have actually this. Okay. So since we have this, now we have to convert this into mantissa an exponent, and it's positive value. Remember that. So what I will do now is, so I need to normalize this. So I'll shift this towards the left-hand side. 1, 2, 3. So if I do so, I'll end up with this 0, 1, 1, 1, 0, 1. How many do I have? I have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how you make the mantissa, right? So I repeat again, in order to normalize this, now what do I mean by normalize? Well, let me explain this as well. By normalizing, we means that it should begin with dot 0, 1. Okay, it cannot be 1 dot 1. Okay, so it could be either be 1 dot 0 or it could either be 0 dot 1. It cannot be this. So I have to normalize this. Upon normalizing, I get is this. So 0, and here I get the point, and that's how it goes. So this entire thing gets converted into this. So I have this as my mantissa. Now, what about the exponent? How do we derive the exponent? Well, the exponent, since we shifted this 3 times, 1, 2, 3. So obviously this was 3 times. So we'll have over here is 1, 1, and the rest of them will be 0, because this is what represents this. So 1, 2, 3, because we shifted this 3 times, 2 raised to power 3. So our exponent will be this. We don't have to temper with this because it's a positive value. Now this is actually positive. We are not done yet. So since it says about 2's complement, what we'll do is we'll obviously invert this so that I get 1, 0, 0, 0, 1, 0, 1, 1, 1, and 1. This is 1's complement. In order to convert 2's complement, I will add 1 to it. So if I do so, what I get is 1, 1 is 0, 1, carry forward. 1, 1 is 0, 1, carried forward. 0, 1, carried forward. Okay, then I get, so 1, 1, 0, 1 gets carried forward. I get 1 here, I get 1 here, and obviously then I get 0, 0, 0, and 1. So this is what I get over here. I get 1, 0, 0, 0, 1, 1, 0, 0, 0, right? And probably another 0, right? So this is what we get for the mantissa. and this is for the exponent, right? I hope it's clear. So let me check this again. So it's 0, 1, 0, 1. So 0, 1, 1, 0, 1, 1, 0, 0, 0. Yes, fine. So this is what we get. Now, since it was negative value, obviously you can see over here is this has to be 1 because it's negative value. Okay, so you can even check this yourself that if you add this up, this will be actually negative minus this. So this is how you get this, right? Then it says calculate the dictionary value of the given floating dictionary value of a given binary floating point number showing you working. Okay, so we need to find is the dictionary value of this. So over here I have is 1, 2, 4, which is actually 7. This is equals to 7. So what I'll do obviously is I'm going to shift this. So initially what I'll have is I'll have it over here. So I'm going to shift it 7. So I'll 1, 2, 3, 4. Sorry for my 5, 6, 7. So I have my point over here. So what do I have over here? So if I have this over here, my since so exponent will help me to basically shift my point from the left to right. So this is actually now my exponent, and that is my mantissa. So this is technically this is what we have is 0.5 plus 0.25. So this is actually 0.5, and this is 0.25, which is actually 0.75. So this value. If you look at this particular value, what do we have here? Well, you just have to look at this. So let's have a look what this value is. Well, this is 1, 2, 4, 8, 16, third, sorry for my writing, actually using my mouse, not using my pen, 32, and then obviously I have is 64, and this one is obviously 128. Now, since it's 1, I think so you do know this and you do remember this, that once you have this as 1, this 128 is negative. If it's 1, it's negative 128. So obviously, if you negative 128 plus you have 32, and then you have plus 16, okay, and then you say plus 1, you will actually end up having 32, 16, 1. You'll have 79. So minus 79. So you have is minus 79, and then you have 0.75. So obviously plus 0.75. You will actually end up with minus 78.25. This is what you will have. I hope this is clear how this point is actually done.